Hi everyone, and welcome back to our exponential equations lesson. Now, in this lesson, we will see that our exponents are rational exponents. So here it's a little bit different from our previous lesson where our exponent was actually a variable. So we tried to make the basis the same. Now here we can easily see that our exponent is a rational exponent. So we have to do something different. It's a different kind of exponential equation. So the same steps apply here as in normal exponential equations. Now what are those steps? We want one term equals one term. So we always remember that they don't always work out so easy as this one. We want to move our constant terms. We want to simplify. We want to divide with our coefficients. And then until we have the simplified variable term equals a simplified constant term or simplified other term, right? So that it's one term simplified equal to one term simplified. Then, now that we have rational exponents, the steps are really easy. We just simply raise both sides to the power of that rational exponent. Now that's the rational exponents. We're going to raise both sides to that exponent's reciprocal. Now, let me show you quickly what is a reciprocal again. If we talk about the reciprocal of a third, it will simply be 3/1. It is that fraction swapped around. So if I talk about 2/5, what will be the reciprocal? It will just be 5/2. Okay, great. So, x to the power of a third equals 2. Well, it's simplified one term equals a simplified one term because I cannot take them any further than they already are. And then I'm just simply going to raise this side to that rational exponent's reciprocal, which is 3/1. And I do exactly the same on the other side. Okay, because what I do on this side, I have to copy on that side. Exactly the same. So this will simply be, I write the x, and a third times 3/1 is a 1, and then basically 3/1 is a 3, so 2 to the power of 3 is 8. And there I'm done, x equals 8. Easy enough, isn't it? Okay, so let's go and look at this example. Again, this is my variable term because there's the x, that's my constant term, but my variable term still has a coefficient. I can divide with the coefficient on the other side. So this will become x, and we still have the 3/2 equals 54 divided by 2 equals 27. Now in exponents, when we were busy with those lessons, I showed you that if we have a rational exponent, we always want to take all our bases and we want to rewrite them as a product of their prime factors. So let's just do it here as well. So here I have x to the power of 3/2 equals, and a 27 is a 3 to the power of 3, right? So now we know that this is a simplified variable term. That is the constant term as simplified as far as possible. And why did I do this? Because we have a rational exponent. So now I want to raise this side to that reciprocal, which will be 2/3. And I want to do the same on this side, which will be 2/3. And then I can simply write my x. And then we know that 3/2 times a 2/3, when we take a fraction and we multiply it with its reciprocal, we always get a 1. So this will be x to the power of 1 equals, and then 3 times 2/3 just gives me, we write the 3, which is the base, and then we multiply those two exponents, right? The one on the inside with the one on the outside. And that will just give me a 2. So x equals, and what do we get? 3 to the power of 2, which will be a 9. And there we go. So how did I know I'm supposed to take that 27 to its product of prime factors? Because we have a rational exponent in our equation. First step, divide with the coefficient on the other side. Take that base, rewrite it as a product of its prime factors, because I'm not allowed to use my calculator, and it's very easy to multiply a 3 with a 2/3 instead of a 27 to the power of 2/3, right? Okay, so how about this example? Here we will just write x stays 3/2. That's a simplified variable term. 0,125 is a 1/8. And now we want to rewrite that and break it up into its product of prime factors, which will be 1 over 2 to the power of 3. And then we don't want to work with that fraction, so I'm just going to apply my exponential laws here. So it will be 2 to the power of negative 3. And then let's raise this side to its reciprocal, which will be 2 over 3. We do exactly the same on that side. See, I copy exactly what I do on this side on the other side, and now we just simply use our exponent law. So I write my base and I multiply the exponent on the inside with the 1 on the outside, and I'm supposed to get a 1 because any rational exponent multiplied with its reciprocal gives me 1. And this will give me 2. We write the 2, which is the base, and then minus 3 times 2 over 3, which will give me a minus 2. So that gives me x equals 1 over 2 to the power of a positive 2, which is 1 over 4. And my answer is x equals a quarter. And that is it. And how about the last one here? Again, we have our variable term equals one constant term. There's a coefficient. I have to divide with it first. So this will be x to the power of a half equals 2 over 3. Okay, I don't want to work with decimals. You see, I changed the decimal to a fraction, so it's better to work with fractions. Now, we've got our variable term that has a rational exponent equal to a simplified constant term. So what I want to do is just raise this side to its reciprocal, which is 2 over 1. We do exactly the same on that side. So this will give me x, and then we know that a half times 2 over 1 is a 1. So that will just be x to the power of 1. And this gives me everything in this bracket to the power of 2, which is 4 over 9. And I am done. Okay, excellent. So let's go and try some more examples. Now here are 2 examples for you to try. Give them a go. And remember, once you see rational exponents, you always want to write the bases as product of their prime factors. And then always, when we are also done with writing the big bases as a product of their prime factors, we want to continue and raise the variable side to the rational exponent's reciprocal and do exactly the same on the other side. Well, that's just my words. You're supposed to know them from the steps earlier on, and give them a go and see if you can get this done. That's a tricky one, so see if you can combine our previous lesson with this one. So here we go. Now here we can simply write x is 3 to the power of 3 over 4, and this will be 3 to the power of 3. Why did I do that? Because we're busy with rational exponents. Always. When I've got rational exponents, I take my bases, I rewrite them as a product of their prime factors. Now, let's raise this side to its reciprocal, which is 4 over 3. We do exactly the same on the other side. And now we will have x equals, because those two multiply just gives me a 1, right? And then here we have, write the 3, and then 3 times 4 over 3 is 3 to the power of 4. So x equals 81. And there we go. And you can simply take that 81, put it in x's place, raise it to the power of 3 over 4 in your calculator, and you'll see you'll end up with 27. Now, but we have to do it like this because now I showed the steps, and you can always go and test your answer with your calculator, right? Now, how about this one? Interesting question, because we've got a rational exponent and one of our exponents is a variable. So what do we want to do when x is a variable? We want to make these bases the same. And because we've got a rational exponent, we want to take the number base and rewrite as a product of its prime factors. So quite easy if you remember it like this. So x minus 1 equals 2 to the power of 3, and that's 2 over 3, right? Okay, so look, that kind of the rational exponent gave me the clue that I want to rewrite the 8 as a product of its prime factors, and I'm done. So now we just have 2 to the power of x minus 1 equals, write the 2, and then 3 times 2 over 3 is 2 to the power of 2. Now look closely. Just by doing that, And now, since x is an exponent, we want the bases to be the same on both sides. Well, they are. So basically, that 2 and 2 can fall away. So x minus 1 equals 2. So x equals 2 plus 1, because we need to take that 1 to the other side. So it becomes a plus 1. And then x equals 3, and I'm done. I just put this one in here so that you can see when I see a rational exponent, I want to take my number bases and rewrite them as products of their prime factors. There's a rational exponent, rewrite the number base as a product of its prime factors, because it makes that multiplication easier. But here x was a variable and we ended up with x with the rational exponent, so raise it to the reciprocal of the rational so that we can have only a x to the power of 1, which is x equals and whatever that side gives me, right? Here x is an exponent, so what do we want to do? We want the bases to be the same. And the first clue is rational exponent, rewrite the 8 as a product of its prime factors. Just do the exponential law. And now, whoa, look there, the bases are the same. So since they are the same, it means my exponents have to be the same, and then we just simply solve for x normally. Great, so I hope to see you again soon, and keep practicing. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.